Today I want to talk about scientific notation. And we're going to be able to do this because we now know positive exponents. We also know more about negative exponents. We can do very large numbers. Look at this number here. Oh, pretty amazing, pretty amazing. This is a big, 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 giant number. Okay, and this one here is a, oh my gosh, little tiny, tiny, tiny number. And so if we were going to write this in use, in practical life, scientists and mathematicians, they would not write it like this. They would not write all these place values. They use scientific notation, and it's mostly used in science. Okay, I just want to look over here on the left. Scientific notation is written this way. A, which is a number that is more than 1 and less than 10. Okay, so I could write it like this. A is more than, greater than or equal to 1. It can also be 1, but it has to be less than 10. It can only be one digit. It's just one digit. And then you're multiplying it times a power of 10. I do want to look down at the bottom here in the red, and I do want to remember what we did in the last video with negative exponents. Remember that a to the negative 1 is the same as 1 over a, or divide by a. Remember, we were going to the left, 10 to the negative 1 is 1 over 10, right, to the positive 1, or I got there by dividing by 10. Remember that 1 over 10 is the same as 1 divided by 10. And so 10 to the negative 2 would be the same as 1 over 10 to the second power, or remember I got there by dividing by 10 to the second power. Okay, so that's going to be important to remember when we look at scientific notation. Now we're looking at this big number, and we just want to scream. It's so big, but we know that we're going to know how to manage this number. Now I'm looking for every digit until it's just zeros. So I'm going to focus on this number. This is the number I'm going to focus on because the rest is zeros. So I'm going to write that down. That's 90463. Okay? And I need that number to be greater than 1 but less than 10. So I'm going to put my decimal point right here because I know that 9 is greater than 1, and it's less than 10, so I'm good. Now I have to figure out what power of 10 I'm going to multiply this by. So this is going to be some power of 10. Okay, so I'm looking at this, and I'm thinking, what would I have to multiply this number by? How many tens would I have to multiply this number by to get this big one? Okay, so let's see. If I was here, I would be multiplying by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 times I'd have to multiply by 10 because I know that every time I move the decimal point once to the right, I'm making it bigger and I'm multiplying by 10. So that's how I know what power of 10 I'm multiplying by. Okay, so this is the scientific notation for this. And you can see it's a lot shorter. We're like, yay, okay, that's great. That's way shorter than adding all those zeros. So again, I took the first digits. I stopped when I didn't have what they call significant digits. Nothing that isn't a zero. Zero is not significant in writing scientific notation. I wrote down those numbers, 90463, and I said, where do I put the decimal point in that number that number is greater than 1 but less than 10? Then I wrote the number. Now I have to figure out, if I put the decimal point after the 9, how many places do I need? How many times am I multiplying by 10? And that's basically scientific notation. But we can also do it for little teeny numbers. Look at this number. It's so small. Okay, so I'm saying, where are the significant digits? Well, they don't start till here. Here's the significant digits. Okay, so I have 3, 9, 3, 0, 1. Now I have to look at that number and say, where would I put the decimal point that's greater than 1, greater than or equal to 1, but less than 10? Well, I'm going to put it right after the 3, because 3 is greater than or equal to 1, and it's less than 10. But now I have to figure out, if I put the decimal point here, how many places have I moved it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And in this case, I'm dividing by 10. And we know that if we're dividing by 10, remember it's times the power of 10. If we're dividing by 10, that net now is a negative 10, because negative 10, okay, means that I'm dividing. That exponent says I'm dividing, or I'm using the reciprocal to multiply by. So that is scientific notation. That's a shortcut version of it. You'll be doing more in Con, so practice, so we can tell whether we are really getting it. Please make sure you have all these notes in your notebook.